In the last video, we talked about how to graph an equation just by plotting points. In this video, I want to talk about a different technique using what's called x and y intercepts. If we have a line that looks like this right here, the x-intercept of this graph is the point right where the line intersects with the x-axis. So that's a point, and it's the point 2, 0. And you might realize that no matter where this graph intersected the x-axis, the y value of the x-intercept would be 0. This graph also has a y-intercept. It's right here. And the y-intercept in this case is 0, -3. And likewise, you might realize that no matter where this graph intersected with the y-axis, the x value is always going to be 0. Okay, but what if we weren't given a graph of a line? What if we were just given the equation of a line? What if we wanted to find the x and y intercepts of the equation 2x plus 3y equals 12? Well, to find the x-intercept, we can use the knowledge that we gained from looking at the graph above. We know that for all x-intercepts, the y value is going to be 0. So if we go back down, what we can do to find our x-intercept is set y equal to 0. If we plug y equals 0 into our equation here, that term goes to 0, and we're just left with 2x equals 12. Divide both sides of this equation by 2 to get x equals 6. So we know that when y equals 0, x equals 6. That x and y value gives us a point. The point is 6, 0. And that point is the x-intercept for this graph. Let's find a y-intercept. We know from the graph above that for all y-intercepts, the x value is going to be 0. So we're going to set x equal to 0. If we set x equal to 0 in our equation up here, we get this. This first term goes away completely, and we just are left with 3y equals 12. Now if we divide both sides by 3 to get y by itself, we get y equals 4. And now that we know that x equals 0 and y equals 4 is a point, we write it down, and that is our y-intercept. Why don't we graph this x in this y-intercept? Let's see, our x-intercept is 6, 0. 3, 4, 5, 6, 0 is right here. And our y-intercept is 0, 4. 1, 2, 3, 4. And we already know that this is the form of a line, or what we call a linear equation. So we know that if we have these two x and y intercepts drawn correctly down here, that the graph of 2x plus 3y equals 12 is just going to be those 2 points connected by a straight line. And what we just did there is that we graphed the line 2x plus 3y equals 12 simply by finding the x and y intercepts, by plotting the x and y intercepts, and then connecting them with a line. Let's do this one more time before I get you a quiz. Let's graph this line by finding the intercepts. If we want to find an x-intercept, again, what we always do is set y equal to 0. You plug in y equals 0. This term is going to go away completely, and we're just going to be left with x equals 6. So we know that when x equals 6, y equals 0, and that's a point. The point is 6, 0. And we know that whenever we want to find a y-intercept, we can set x equal to 0. If we plug x equals 0 into our original equation, we get this here. And that's just -2y equals 6. Now if we want to isolate y, we have to divide both sides of the equation by -2. 6 divided by -2 is -3. So we know that whenever x equals 0, y equals -3, and we have a point, 0, -3, which is our y-intercept. Okay, now let's graph those x and y intercepts. 6, 0 is right here, and 0, -3 is going to be down here. And we know that since this equation is represented by a line, that line is going to connect those x and y intercepts, and that's going to be the answer. Okay, we've done a couple of examples now. See if you can do it. Here's your video quiz. Graph this line using x and y intercepts. Good luck, and I'll see you in the next video.